The objective of this lesson is to explain the patterns of decimals and decimal placement when multiplying by powers of 10. We will be able to use exponents to denote powers of 10. Students are familiar with finding 10 times a number. However, they will need to understand the following vocabulary for this lesson. An exponent is the number that identifies the power to which the base is being raised. This is the number of times the base is repeated. The base is the number that is raised to a power. Let's begin with a problem that would involve multiplying by powers of 10. Charlie says his dining room table at home seats 6 people. He says that the school library seats 10 times more than that, and the cafeteria seats 10 times more than the library. How many seats are in the cafeteria? This is a problem that we need to break into smaller steps. Charlie has 6 seats at the dining room table. Let's write a 6 on the place value chart. If the library has 10 times more, I know that I need to multiply 6 by 10. This equals 60 and moves the digit 6 one place to the left, which is the tens place. 60 is the number of seats in the school library. However, we are looking for the number of seats in the cafeteria, which has 10 times more than the library. That means that I need to multiply 6 tens or 60 by 10, which will move the digit to the right one more place and equal 6 hundredths. This would be the same as multiplying 6 by 10 and then 10 again. The cafeteria has 600 seats. Writing the equation this way with repeated tens is not very efficient. In 3rd grade, students learned that multiplication is a more efficient way to write and solve repeated addition problems. However, now instead of repeated addition, we're working with repeated multiplication. Exponents are an efficient way to write equations with repeated multiplication. For instance, in this problem, 6 times 10 times 10, we are multiplying 6 by 10 2 times. We want to write this in exponential notation, also known as scientific notation. Let's write 6 and multiply it by the base, which in this case is 10, and for the purposes of 5th grade will always be 10. We notice we multiplied by 10 2 times, so we will write the exponent of 2. Notice the exponent is written smaller than the base and is positioned to the top right of the base. This now shows 6 times 10 to the 2nd power. Sometimes students think that 10 to the 2nd is the same as 2 times 10. This is a good time to stop and ask them if this 10 to the 2nd power is the same as 2 groups of 10 or 2 times 10. They should see that 20 is not the same as 10 times 10. Now, referring back to our original problem, imagine that Charlie's hometown has an amphitheater that seats 10 times more than the cafeteria. What is the seating capacity of the amphitheater? We know that the cafeteria can seat 600, so we would multiply this by 10, which is 6,000. Looking at our chart, we multiplied the original 6 by 10 3 times, so we could write 6 times 10 times 10 times 10. Let's rewrite this in exponential notation. We can see that 10 was multiplied 3 times, so the exponent is 3. This shows 6 times 10 to the 3rd power. Important to note, by this point, students may start to think that the exponent is related to the number of zeros in the product. In this sample problem, 6 times 10 to the 2nd power, the exponent is 2 and there are 2 zeros in the product. In 6 times 10 to the 3rd power, the exponent is 3 and there are 3 zeros in the product. This pattern would continue in this example, however it does not hold true for all numbers. What if we worked with a number like 5 and 4/10? If I multiply by 10 one time, this could also be written as 5 and 4/10 times 10 to the 1st power, which just means I multiplied the number by 10 one time. The exponent is 1, so your child might anticipate 1 0. But as you can see, there are no zeros. However, looking at a place value chart, notice that the digits did move one place to the left. If I multiplied 5 and 4/10 by 10 2 times, I would write this as 5 and 4/10 times 10 to the 2nd power. The exponent is 2, but there is only 1 0 in the product. But notice again that the digits moved over 2 places from their original position. If we continued this with exponents of 3, 4, and so on, you would notice that the exponent does not relate to the number of zeros in the product, but to the number of places that the digits move to the left. Let's look at one more problem. The distance from the Earth to the Moon in miles is 23 and 89 hundredths times 10 to the 4th power. Evaluate the expression to find the distance. Thinking back to our other examples, we know that we are multiplying 23 89/100ths by 10 4 times because the exponent 4 is with a base of 10. Every time we multiply a number by 10, the digits move one place to the left. Since we are multiplying the number by 10 4 times, we need to move the digits to the left 4 times. The distance from the Earth to the Moon is 238,900 miles. The objective in this lesson was to explain the patterns of zeros and decimal placement when multiplying by powers of 10 and use exponents to denote powers of 10. We met this objective by using a place value chart to look for patterns as we multiplied numbers by powers of 10.